Hello, class. This will be the second of the recorded lectures for 4.3, which talks about quadratic functions. We're going to go through a really big and probably important example on calculating all the attributes and sketching a quadratic function. And so we talked about this in the last lecture, but just to reiterate a couple things that are in the PowerPoint presentation, which will also be uploaded for your viewing pleasures. And so again, calculating maxes and mins. It's the answer will always be the vertex. So, and remember that we talked about when the a value is greater than 0, the parabola opens up. And so the vertex will be the min. And when the a value is less than 0, the parabola opens down and the vertex will be the maximum. And we showed this on the last one. Just want to reiterate because it is, when you do applications, usually you're trying to find maxes and mins. You'll go into calculus and learn how to take a derivative. And that also gives you the capability of calculating maxes and mins for more complicated functions. The other thing that we introduced in the last recorded lecture was this axis of symmetry. And just want to reiterate that it is the equation of a vertical line that splits the parabola in two. And so here is our axis of symmetry that splits it in two, and it's symmetric around that axis. And the equation of that line is x equals the vertex and the x value of the vertex. And you can see this is the fancy book equation for that. And so what we'd like to do now is walk through this particular example. And so I picked a equation x squared minus 4x minus 5. So let's take a look at this. And let's walk through all these on the whiteboard here. So I'm just going to use y minus 4x minus 5. And so the first question says find the vertex. So the x value, whoops, oh, I like to do this, so I should follow my suggestions. Because again, if I don't do this, I tend to screw up the signs of a couple of these. And so it's good to do that. So the x value is minus b over 2a. So when we do this calculation, minus 4 divided by 2 over 1. And so that would be 2. So the x value is 2. What is the y value? Well, the y value would be, the vertex would be 2 squared minus 4 times 2 minus 5. And that looks like 4 minus 8 minus 5. And that would be minus 9. So the vertex is 2 minus 9. So the a value is greater than 0. So the u is going to be pointing up. And so is the vertex a max or a min? The vertex is a min, right? Because the vertex would be right down here. So we haven't even sketched anything, and we know what the vertex is. Or excuse me, that the vertex is a is a min. What's the axis of symmetry? Well, that would be the x equals the x value of the vertex. And so that would be x equals 2. So we answered quite a few of these questions already, and we haven't even thought about sketching yet. And so we've answered first one, second one, and now we're going to, in the third one where the vertex is a min. So now let's find the intercepts. So going back to the whiteboard, we will take a look at the intercepts. So I need a little bit of space here, so let me. Well, while I'm erasing, I could definitely state that what is the y-intercept? Well, the y-intercept is the constant value that we have in our equation, and you could see that the y-intercept would be -5. So usually the y-intercept is quite easy, if you can read it. If it's in its standard form, bx equals 0, y equals -5. The other one is that when y equals 0 is the x-intercepts. And this one is factorable. But I think it would be nice just to walk through step by step of the quadratic formula. Some people, let me rephrase this. In real world applications, when you get a quadratic as a model, it always is not factorable. So you always have to use a quadratic formula. So again, it's -b plus or minus the square root of b squared minus 4ac all over 2a. And so the strategy is always do b squared minus 4ac first. Because if it's negative, you're done and there's no x-intercepts. So let's see what we get. So b is -4, so it'd be -4 squared minus 4 times a is 1 and times c is -5. See, that's why it's nice to have this written up there. So this looks like this would be 16 plus 20. So that would be 36. So then we have to take the square root. So what's the square root of 36? That would be 6. So it looks like we're going to have two solutions for the x-intercepts. So you finish the equation, so it'd be -4 plus or minus 6 all over 2 times 1, which is 2. So we could divide or simplify here, right? Plus or minus 6 over 2. And so one answer would be 4 plus 6 divided by 2, which is 5. And the other one would be 4 minus 6 divided by 2, which is -1. So here are your two x-intercepts, 0, 5, and whoops, that is backwards, 5, 0, and -1, 0. And some of you would look at this and say, oh, that could be factorable. Yes, it was a factorable equation as well. So the next thing I want to do is show you what I think is a really good approach to sketching a quadratic. And I like to call this the 5-point approach. And the 5-point approach is you first need to find the vertex. And then you find, because of the symmetry of the axis of symmetry, if you move 1 point to the right and 1 point to the left of the vertex, you're going to get the same y value. And since we know that the vertex is right there at the axis of symmetry, you can get a really good sketch with 5 points. When you sketch a linear equation, you only need 2 points. And in my opinion, when you sketch a quadratic, you should have 5. The book has a little different approach, and I'll talk about that as well. So let me find some room here. And do a little erasing. So we've done all these calculations, right? And so let me show you what I mean about the little sketch. So what I like to do is make a little table of the 5 key points. And the 5 key points are, you want to start with the vertex. And so literally every time you do analysis with a quadratic, you're probably going to end up with the vertex. So let's put it down here. X equals 2, y equals -9. So what I mean is you want to move +1 value of the x from the vertex. So the vertex x value is 2. You add 1 to that, you get 3. So what is the y value? You got to plug it in and figure it out. So it's a little bit of work. 3 squared minus 4 times 3 minus 5. So that would be 9 minus 12 minus 5. So that looks like that would be -8. And so what's next? Well, then you subtract 1 from the x value. And so it would look like 2 minus 1. And this has to be the same value as the one that's 1 greater than. That's what we mean by symmetry. And so if you do that, you would get 1 squared minus 4 times 1 minus 5. And you could see that's 1 minus 9. And again, that's -8. You say to yourself, okay, I did that right. Or once you get feeling comfortable, you can just write that answer down. So there's really only 3 calculations you have to do. Okay, so what's the last one? Well, the last 2 points are we want to move 2 from the vertex in both the plus direction and the minus direction. So if you add 2 to the x value of the vertex, you get 4. So what do we get here? 4 squared minus 4 times 4 minus 5. And so that looks like that would be -5. And you know, when we go to the negative side of the vertex, x value of the vertex, we get to 0. And when you plug 0 in, you would get -5 as well. So when you sketch these, it would look like this. I need more negative here, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, -10. And we're on the positive side here. So let's do a few of these. So +2, -9, the vertex is right here. And then we go to +1, -8 is right here. And +1 or +3 is also -8. And then the 0, which is our y-intercept, right, would go right here at, whoops, wrong one. I think that's 6. Oh, that's not what I wanted to erase. Put that back in. So 1, 2, 3, 4, 5 would be right here. And then x equals 4, y equals 5 would be right here. And so you could see that if we start sketching this up, it would look like that. And the a value is positive, right? So we know it's opening up. So what are the other 2 points we have? Well, we have these 3 other points that we should always use and think about. The first one was the y-intercept, which we've already put in. So what's nice is you have these. So let's put in the 2 x-intercepts. So it'd be here at x equals 5 and at -1, which would be right here. So when you sketch these things, looks just like that. What is the axis of symmetry? Put that in blue. It'd be this line right here. And that would be the x equals 2 line. And you could see that when you move in either direction to the right or left the same amount, the y values are going to be exactly the same. And so that's what we mean by that axis of symmetry. So that's a good example of what I consider the kind of the 5-point approach to those calculations. And so that is 1, 2, 3, the fourth one down. And so let's finish this with talking about domain, range, and where the function is increasing and decreasing. And so what we have here, I'll get leave all this up. And I don't need my table anymore, but I do need a little bit of room, so I'll use that for. So the first question is, what is the domain? Well, the domain, hopefully you realize it'll be all real numbers, and that's always the answer for all the vertexes, all the quadratics. And so you could see these arrows imply that you're going all the way to the right to positive infinity and all the way to the left, which is negative infinity. But the range is restricted. It's not all real numbers because the vertex will be one part of the range and plus or minus infinity is going to be the other one. And so the vertex down here is 2 minus 9. So you could see that the y values don't go below the vertex, right? Because that's the minimum value. So we would put a bracket here because minus 9 is included. And then where does it go? Well, going up, it would be positive infinity. So when a is positive, it opens up, and so it'll always go to positive infinity. If a is negative, then it'll always go to negative infinity. So the minimum will always be negative infinity in that case. So where is the function decreasing? Well, decreasing is the negative slope, and that happens on this side of the parabola. So we're going down, 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 down until we get to the vertex. And you always indicate this in an interval notation using the x values. So the x values start decreasing from minus infinity all the way till we get to the value of 2. And then what happens next? We would be increasing from 2 all the way to positive infinity. And I believe that answers all those questions on our example sheet here. Yeah. So this really is a really good example of all the attributes and important concepts of the quadratic. In the next recorded lecture, we're going to start introducing using quadratics in real-world modeling, and we're going to go through 3 different concepts. The first one is a business concept with profit, revenue, and cost. And so that'll be the next recorded lecture. And so this ends the recorded lecture for the second part of section 4.2.